We're going to be measuring static pressure today, and static pressure is the pressure related to the state of a fluid, in this case a gas, the air moving through an HVAC system, instead of its movement. So we're just going to be measuring that pressure. It's related to Pascal's law, which is basically if you contain a gas or a fluid inside a container, it's going to put an equal amount of pressure on all sides of that container. This is the static pressure Pitot tube that we use to measure static pressures. So this Pitot tube has a tip that's solid, and it's got these little holes on the side right here that will measure the static pressure. It's got holes on the other side as well. Now the best practice is to insert this into the supply plenum and the return plenum, and then orient it so that this tip, while it's covered and it's solid, is pointed in the direction of the airflow. And the reason why is that most HVAC technicians are trained to insert their pressure probes that way. And you're going to be measuring it in the same orientation. If you change the orientation of that probe, you're going to end up with a different pressure reading than what they got, just because the turbulence is different in the different zones. So this is going to get inserted in the supply plenum, return plenum. I use two probes, one for the supply, one for the return, connect them here with the tube to my DG700 gauge. I've compared the DG700 with MagnaHelix. They're going to be just about dead on if you do the exact same orientation and place them in the same position in the return plenum and the supply plenum. So this is the DG700 gauge that I use. Now what we'll do is we'll connect one side to the static pressure probe that's on the return side of the air handler, one side that connects to the static pressure probe that's inserted into the supply side of the air handler. Basically, you turn the gauge on, keep it at reading pressure, change the units, the unit button right here, change that from pascals to inches of water column, and so now it should display INWC, that's inches of water column. And you can see we're out here, it's a little bit windy, and it's bouncing all over the place. And when we connect our pressure probes up there, what we will do is the side that's connected up to the return side of the air handler is going to read a negative number. The side that's connected up to the supply side of the air handler on the supply plenum is going to read a positive number. And to take a total external static pressure, you just ignore the positive and negative signs and just add those two values together. And that will give you your total external static pressure that you can then turn around and look at a blower table to confirm what the airflow is for the manufacturer's specifications. So we're up here in this attic and we're looking at a heat pump air handler, which is in a split system. You've got an outdoor coil and you've got an inside coil. Now in this case, this is the return side, so this is connected to the return grill, return duct coming into the return side of the air handler at the bottom end, where we have a coil with the refrigerant lines running through it, and then there's a fan over here that's drawing the air, pulling the air from the house across that coil, and it's pushing it into the supply plenum on this side, where it kind of hammerheads into this T and goes into a reducing trunk system with takeoffs. So the HVAC contractor has provided us with a hole here, and the supply plenum covered with duct tape, and a hole over here covered up with duct tape as well in the return plenum. Always use the holes provided for you by the HVAC contractor, and if the HVAC contractor has not provided those holes for you, please contact them and ask them to make holes for you in order for you to do the total external static pressure test. Now, the other thing is that the values that we're looking for need to be within 0.05 inches of water column. That's our range of tolerance from what the HVAC contractor measured and what you measure. So we're going to come over here, we're going to peel this tape back, and we're going to take this static pressure probe and we're going to insert it into the direction of the airstream, and use the tape to help secure that probe in that position. Now we're going to be taking this static pressure probe and we're going to be inserting it into the return plenum, and again inserting it into the direction of the return airflow and securing it with the tape to hold it in that position. And now we're going to connect the supply side onto the top tap of the DG700 labeled input, and then we're going to connect the return side to the top tap on the other side labeled input. Now that we have the gauge connected, we turn it on. We leave the device alone, so it's going to be reading pressure up here. We press the light button so that it backlights the gauge readings for us. And you'll notice that it's bouncing around. It's in pressure mode. We change it from reading pascals to reading inches of water column by pressing the units button. And you'll notice again that it's bouncing around. And that's because this gauge is taking a reading right now every second. So if we press the time average button, it's going to take a reading every 5 seconds. And we just wait and see what magic happens. There we go. And you press the hold button, it freezes it so that you can then set the gauge down and make your notes, write down, do the calculation, do the math. In this case, we can tell that this gauge is telling us that we have a 0.1243 inches of water column, 0.1243. And again, we ignore the negative sign over here, which is measuring the return side pressure, and we ignore any positive signs. We're just treating them as individual numbers with no positive or negative values associated with that.